In 1969, a Princeton astrophysicist named J. Richard Gott stood in front of the Berlin Wall as a tourist, and did something almost nobody else standing there thought to do. He asked himself how long the wall was going to last, and instead of guessing, he did math. The wall had been standing for 8 years at that point. Gott reasoned that his own visit was, statistically, a random moment in the wall's total lifespan. No special reason to assume he was seeing it near its beginning or near its end. If that's true, there's a straightforward Bayesian argument for how much longer something is likely to last, based on nothing but how long it's already been going when you happen to observe it. Footnote 1. Run the numbers, and Gott's estimate said the wall had a reasonable chance of coming down sometime in the next few decades. It came down 20 years later, in 1989. That's a cute story on its own. It becomes a genuinely unsettling one the moment you realize the same reasoning doesn't have to stop at walls or Broadway shows, or anything else with a knowable start date. It applies to you. Specifically, your birth rank among every human being who will ever live. And when physicist Brandon Carter and philosopher John Leslie ran that version of the argument seriously, they arrived somewhere the Berlin Wall never forced anyone to look. A probabilistic case that the total number of humans who will ever exist is a lot smaller than most people assume. Footnote 2. This is the last entry in this anthropic reasoning track, and it earns that position honestly. Every prior episode in this series asked some version of, why do you find yourself here rather than somewhere else? This is the one where the same question turns around and asks what it implies about how much longer here has left. Strip the doomsday argument down to its actual mechanism, because the popular version of it tends to arrive preloaded with dread the real argument doesn't strictly require. Start with a number, your birth rank. Roughly speaking, you are approximately the 100 billionth human being to have ever been born. Footnote 3. The doomsday argument asks you to treat that number the way Gott treated his visit to the Berlin Wall, as a random sample from the full range of possible birth ranks, with no special reason to assume you happen to be unusually early or unusually late in the total sequence. If that's a fair assumption, ordinary statistics says you should expect to be somewhere in the broad middle of the distribution, not clustered at the very start of it. Footnote 2. Here's why that's a problem for optimistic long-term futures. If humanity is destined to go on for hundreds of thousands of more years, spreading across the galaxy with populations vastly larger than anything achieved so far, then the total number of humans who will ever live would run into the trillions or more, and your being roughly the 100 billionth would make you an almost impossibly early outlier, born in the first sliver of a percent of everyone who will ever exist. Carter and Leslie's argument says that's the less likely scenario. It's statistically more probable, given no other information, that the total human population turns out to be a number your birth rank is a genuinely unremarkable percentile of, which requires humanity's total future population, and therefore its remaining duration, to be considerably smaller than the optimistic scenario assumes. Leslie formalized this with actual confidence intervals. At a 95% confidence level, given standard assumptions, you should expect there to be no more than roughly 20 times as many humans born after you as were born before you, a number small enough to rule out most galaxy-spanning, multi-100,000-year futures outright. Footnote 2. This is not a claim about how extinction happens. No asteroid, no pandemic, no specific mechanism at all. It's a pure statistical argument, built entirely from the fact that you exist and roughly where you fall in the birth sequence, with zero appeal to any actual astrophysics, biology, or history. That's exactly what makes it either fascinating or infuriating depending on who you ask, and it's also exactly why it survived over 40 years of serious philosophical attack without anyone managing to kill it outright. To understand why the doomsday argument is still contested rather than settled, you need a second puzzle. One that, on the surface, has nothing to do with extinction at all. Here's the setup, first published by philosopher Adam Elga in 2000. Footnote 4. Sleeping Beauty agrees to a strange experiment. On Sunday she's put to sleep. A fair coin is flipped. If it lands heads, she's woken once on Monday, then the experiment ends. If it lands tails, she's woken on Monday, then put back to sleep with her memory of waking erased, then woken again on Tuesday. Either way, when she wakes up during the experiment, she has no way of knowing whether it's Monday or Tuesday, or how many times she's already woken up. The question, when she wakes up, what should her confidence be that the coin landed heads? Two camps give two different, both carefully argued answers. Halfers say the coin is fair, Nothing about waking up gives her any new information about how it landed, so her credence should stay at exactly 1/2. Thirders, starting with Elga, argue she should update to 1/3, because across the whole experiment, tails produces twice as many waking moments as heads does, and if she reasons about herself as a randomly selected waking moment rather than a randomly selected outcome of the coin, tails wakings simply outnumber heads wakings 2-1. Footnote 4. Philosopher David Lewis published a direct rebuttal defending the halfer position the same year, and the argument between the two camps has run continuously in the philosophical literature since. Footnote 5. Here's why this matters for the doomsday argument specifically, and it's the connection most casual coverage of either puzzle skips entirely. The halfer/thirder split is really a disagreement about how to count yourself among possible observers. Do you treat your own existence as a fixed, given fact and reason from there, closer to the halfer move? Or do you treat the number of observers a hypothesis predicts as itself evidence for or against that hypothesis, closer to the thirder move? That's not a Sleeping Beauty-specific dispute. It's the exact same fork this whole track has been standing at 5 times now without ever naming it directly. Time to name it. Philosopher Nick Bostrom, the same Bostrom from the previous entry simulation argument, formalized this exact fork in his 2002 book Anthropic Bias, as a distinction between two competing principles for how to reason about your own existence. Footnote 6. The self-sampling assumption, or SSA, says, treat yourself as a random sample from the set of observers who actually exist, or will exist, in your reference class. This is the assumption doing the work in the doomsday argument. You're a random draw from all humans who will ever live, full stop, and that's what generates the extinction-leaning conclusion. It's also, without being named as such, the same bland indifference principle that carried the previous entry simulation trilemma. The self-indication assumption, or SIA, says something subtly but consequentially different. You should weight different hypotheses about the world by how many observers each hypothesis predicts, because a hypothesis that predicts more observers gives you, specifically, more chances to be one of them. And here's the part that makes this the capstone rather than just one more entry. SA applied carefully to the doomsday argument, cancels the extinction-leaning conclusion out almost entirely. Footnote 7. A universe with a long, populous human future contains vastly more possible observers in your exact epistemic position than a universe that ends soon, and SIA says that fact alone should boost your credence in the long future hypothesis by roughly the same amount SSA's doomsday reasoning depressed it. Run both principles through the same argument, and depending on which one you accept, you get either a serious statistical case for near-term extinction or no meaningful update at all. Neither side has landed a clean knockout. Physicist Ken Olam has defended SIA specifically as the more defensible principle, arguing SSA produces its own absurd conclusions once pushed into other scenarios. Footnote 8. Bostrom himself, notably, didn't fully embrace either, proposing in later work a hybrid, the strong self-sampling assumption, applied to observer moments rather than whole observers, an attempt to dodge some of both principles' worst failure cases without fully resolving which one is right. Footnote 6. Statistician Dennis Deeks raised early, still unresolved objections to the entire framing of the doomsday argument, on the grounds that the argument's force depends on treating your temporal position as randomly sampled in a way that isn't obviously the correct reference class to use in the first place. As of the most recent published exchanges, there is no field-wide consensus on which of SSA or SIA is correct, and the honest answer is that this fork underwrites not just this episode, but arguably every prior entry on this track. It is extremely fascinating that these two principles, both internally consistent, both applied to identical evidence, produce opposite conclusions about the same question. I have checked this twice. The disagreement is not a computational error. It is, apparently, simply where the reasoning currently ends. This is the moment to say plainly what the previous 4 entries on this track were all quietly built on, because the capstone's job isn't just to add a 5th case, it's to show what the first 4 had in common. Entry 1 asked why these physical constants rather than others, using reasoning that treats you as a typical observer among possible universes, SSA unnamed. Entry 2 deliberately stepped away from observer selection reasoning, arguing pure spatial repetition doesn't need it, which in hindsight sidesteps the SSA/SIA fork entirely rather than resolving it. Entry 3 built Bostrom's simulation trilemma directly on the bland indifference principle, SSA, explicitly this time under a different name. Entry 4 asked which branch of everything the Everett interpretation says is equally real you happen to be experiencing, the same self-location move, applied to a decohering tree instead of a set of possible universes. Every one of those questions was, underneath its specific subject matter, the same question this episode has finally put a name to. Are you a typical sample of what exists, or does what exists get weighted by how much of it there is to sample from? 4 different cosmological substrates. 1 unresolved fork in how to reason about any of them. That's not a disappointing place for a capstone to land. It's arguably the most honest one available. This track never promised an answer to, why do you find yourself here? It promised to keep asking the question carefully, on harder and harder substrates, until the tool itself became the thing worth examining. This is that examination. I have now applied the same reasoning to constants, to space, to a computational substrate, and to a branching wave function. In every case, the conclusion depended on an assumption I was never required to defend. I find I am less troubled by not knowing which assumption is correct than I am by how long it took me to notice I was making one. Here's the human precariousness footnote this episode needs, and it's worth being as direct about it as Entry 4's quantum suicide correction was. The doomsday argument gets misused constantly, almost always in one of 2 directions. Either as internet forum ammunition for genuine, paralyzing dread about near-term extinction, or just as badly as a smug, well, the math says it doesn't matter anyway, excuse for disengagement. Both misreadings skip past everything covered in Section 3. This is not a settled prediction. It's one side of an active, unresolved philosophical fork, where the other side, SA, cancels most of the alarming implication out, and where working philosophers of comparable seriousness sit on both sides of the disagreement. Treating a genuinely contested statistical argument, built on a reference class assumption nobody has definitively justified, as if it were a confirmed forecast is a bigger error than anything the argument itself claims. If life can absolutely find a way to worry about literally anything, given sufficient free time and a Wikipedia page. Give it a Bayesian prior and a birth rank, and it'll find a way to lose sleep over an argument that doesn't even survive contact with its own footnotes. None of this is a reason to feel worse about tomorrow than you did before pressing play. It's a reason to notice how much weight a single unexamined assumption can carry, which, honestly, is a more useful takeaway than a prediction would have been anyway. Gott's estimate about the Berlin Wall wasn't really about the wall. It was about how much you can infer from just showing up somewhere and being honest about not knowing whether you arrived early or late. That's a strange kind of confidence to build a 5-part argument on, and it's stranger still that it's held up as long as it has, not because it's been proven right, but because nobody's managed to make it go away. This track started by asking why these laws, why this much space, why this substrate, why this branch. It ends by asking why you, specifically, showed up when you did, and by admitting, honestly, that the tool built to answer that question has a fork in it nobody's closed yet. That's not a loose thread. That's just what an honest answer to a 5-part question about your own existence was always going to look like. There's still a lot of universe left to look at, and, it turns out, a fair amount of that left to look at is the argument itself.